Hello guys, welcome to the channel. In this particular video, I will explain the problem find maximum equal sum of three stacks. Now the problem is really interesting. Just stay tuned till the end of the video and at last you will have complete understanding of the intuition and approach behind the solution. So let's see the problem statement. Okay, so here is the problem. It says that you are given three stacks S1, S2 and S3 of size N1, N2 and N3 respectively, having only positive integers. Now the task is to find possible equal maximum sum of the stacks, and the operation allowed to us is removal of top elements, right? And as we are given this stacks, so the only operation allowed to us is pop according to the problem. And now the stacks are represented as an array, and the first index of the array represents the top element, right? Okay, so you can see from here as well, like we are given three arrays and this is the top element that we have, first element, right? Now let me explain the problem with this example. So we are given three stacks. Let me draw the three stacks first. So the first stack contains element 4, 2 and 3. The second stacks have 1, 1, 2, 3 and the third stack have 1 and 4. So let me write the sum of the stacks. Like the sum of first stack element is 9. For the second stack we have the sum as 7 and for the third stack we have sum as 5. Now what I can do is I can perform the pop operation on this stack. So if I do so, then I will have the sum as 5, then 7, then 5. These two values are going to remain same. This will now become 5, right? And now I can perform the pop operation on this stack. So if I perform one time, then I will have 5, 6 and 5 as the new sum. And if I perform one more time, then I will have 5, 5 and 5. So this is the first point where I have seen the equal sum of stacks, right? Is this the first is this the maximum possible sum of stacks? So let's see. We have like you can see that, okay, even let me perform the operation. So if all values are equal, then I can perform the operation. Let's say I try to remove this value, then I will have 5, 5 and the new sum will be 4, right? And now if I perform on this one, then I will have 3, then 5 and then 4. You can see that the sum keeps reducing after this point, right? So this is the maximum possible sum. Even you can notice that we are given only positive integers in the stack. So if you try to remove if you try to subtract positive integers from these values, then we will have less sum values, right? So this is the first thing. You can see that the first time we see all equal values, then we will have that particular value as the answer. So 5 is going to be the answer for this particular example. Now I hope you have understood the problem. So let's talk about the solution. Here I have written the same example as given in the problem statement. So let me write the sum again. This stack has sum 9, this stack has sum 7 and then we have 5 for this stack, right? Now what we can notice is the first thing that we can notice is this is the maximum value, right? So if we have 975 as the sum values, then what are the possibilities to make the equal sum? Either we can make all values equal to 9, so this way I will have 999 as the sum, or we can make all values equal to 7, so we will have 7 like 3 times equal values, and or we can make every value equal to 5. So you can see that just have a look here. Can we make all the values equal to 9? Making all the values equal to 9 simply means we have to increase these two values, right? And is it possible to increase these two values? We are only allowed to pop the values, right? And when we pop the values, as we have positive integers only, so we will get less sum values. So there is no way that we can increase any of the value, right? So this means that this particular thing is not possible. And even for like this particular case, you can see that we have to increase 5 to make it to 7, right? So this is also not possible, but this is something which is possible. We can make every value equal to 5. And how we can make this, how we can do this, we can simply try to reduce the maximum value each time. So now let me explain you. You can see that we have the maximum value as 9, right? So we can reduce the maximum value by simply removing the first element. This is the only operation which is allowed to us, right? So this way I will have the new sum as 3 plus 2, which is 5, then 7 for this and 5, right? Again you can see that this is the maximum sum, so I can try to reduce this sum. How to reduce? I'll simply remove the top element, and By doing this, I will have 5, then I will have 6 here, then I will have 5 here, right? After this, again you can see that I have maximum sum as 6, so I can again reduce this sum, and this way I will get 1. So like now the new sum values are 555. This is very critical point. I have already explained this thing to you, that whenever we see the maximum value or like equal values for the first time, then this is the maximum possible equal sum. I am saying this because we are only given positive integers, and when we try to remove further, then we will have less sum values, right? So the two observation that we have is these two. The first is that the first equal sum of the stack element is the maximum equal sum, right? Even you can see here that we got first time we got equal sum, and this is going to be our answer. And the second observation is always try to reduce the maximum element to make equal sum, right? And we have already seen this as well. So we have three values, and we are always trying to reduce the maximum value, you can see here. So now let me try to talk about the approach. So I'm going to draw the three stacks again. So the first stack have 4 2 3. For the second one I have 1 1 2 3, and for the third one we have, okay, 1 and 4, right? So let me write the sum as well. The sum is going to be I have 9, then 7, then 5. So now let's talk about the approach. I will have three pointers. I will have three pointers I, j, and k, each pointing to the current top element of the stack. Right? We have to keep track of top element, because if you are talking about removing the element, you can see that we are removing the elements. So we need to like keep track of the element, which element we need to remove, or which is the current top element, right? So now what we can do is, let's say I have the sum values. So first of all, we are going to calculate the sum values. I have sum1 equal to like sum of element of s1. I have sum2 as sum of element of s2, and I have sum3 as sum of element of s3, right? So this is the first step. After this we can what we can do is, we can as we have this sum value, so we can just see whether the sum is equal or not. So if my sum1 is equal to sum2, and if sum2 is equal to sum3, in that case we can say that the current sum is the answer. So we can simply return the sum1, like we can return any value because all are equal, and we are directly returning the value. The reason is we already know that this is the first time we have seen the sum, right? And when we see the first time, then this is going to be the maximum possible sum. So after this, if the sum values are not equal, in that case we can check what is the maximum value. So if my maximum of sum1, then sum2, then sum3, if the maximum is equal to let's say maximum is equal to sum1, so what to do in that case? If the maximum value is equal to sum1, in that case we need to return the current we need to remove the current top element, and then we will increase the value, right? If I is pointing to this, then I will point to this is the current top if we remove this. So we have to do this. The way we can do this is like we can simply do sum1 minus equal to s1 of I, and then we can simply do I plus plus, right? This is something that we can do. Similarly, if we have let's say the max element is max of sum1, then sum2, then sum3 is equal to let's say sum2. In that case we need to remove the element from stack 2. This is j, right? So I will write sum2 minus equal to s2 of j, and then we can do j plus plus. After this, okay, so first of all let me do one thing, that I'm going to bring it down. So let me select this and let me move it here, right? Now what I can do is I have, if like my sum is not equal to this stack 1 element, maximum sum is not this one or not this one, so maximum sum will be equal to this value. So if the maximum sum is this one, then I have to remove the top element from this stack 3. So I'll write s3 minus equal to like sum3 minus equal to s3 of k, and then I will do k plus plus. Now I have to do this thing repeatedly till my sum become equal, right? So I'll write this thing in a while loop. And when the live while loop is going to break, so let's say this I has reached the end, so there is no any element to remove, right? the stack 1 is empty now, or like this j has reached the end, or this k has reached the end of this stack 3. So I'll write if my I is smaller than like s1 dot size, and my j is smaller than s2 dot size, and my k is smaller than s3 dot size. Till then I have to perform this particular operation, right? And if this loop is completed and we have not seen the equal sum anytime, in that case the equal sum is going to be 0, right? And this is the worst case, like I have removed all the elements from this stack, then this stack, and then this stack. So I will have 3 empty stacks, and 3 empty stacks are going to have sum as 0. So 0 sum is going to be like answer in that case, right? So if I try to zoom this out, then this is the approach that we need to follow. This is the whole approach. Talking about the time complexity of this approach, so this is the worst case where we have removed the element from this stack, this stack, this stack, right? And in one operation we are removing one element only. So in worst case we will run this loop n1 plus n2 plus n3 times. These are the total elements that we have, right? So the complexity in worst case is going to be, time complexity will be O of n1 plus n2 plus n3, and the space complexity will be O of 1, right? We are not using any extra space here. So now I hope you have understood the intuition and approach. Let's talk about the implementation now. So here is the code. I have written the Java code on the left hand side and C++ code and Python code on the right hand side. So the first step is to calculate the sum, as I have explained you, right? And this is how we calculate the sum in Java, C++ and Python. After this, we are going to have 3 pointers, and these pointers are like this is the same thing that I have explained you. While my I is smaller than s1 length, j is smaller than s2 length, and k is smaller than s3 length, I have to check whether the sum are equal or not, right? And after this I'll get the maximum sum, and I will check maximum sum is equal to like s1, like sum 1, sum 2, or sum 3, right? This is how we can solve the problem, and this is the C++ code, and this is about the Python code. So I hope you have understood everything related to this problem. This is all about this video. If you guys like the explanation, then you can hit the like button. Thank you.